3.8. Finding a value given a proportion. Examples 3.5 through 3.8 illustrated the use of software or Table A to find what proportion of the observations satisfies some condition, such as SAT score above 810. We may instead want to find the observed value with a given proportion of the observations above or below it. Statistical software can do this directly. Example 3.9. Find the top 10% using software. Scores on the SAT Evidence-Based Reading and Writing ERW test in 2018 follow approximately the N bracket 531, 104 and bracket distribution. How high must a student score to place in the top 10% of all students taking the SAT? We want to find the SAT score X with area 0.1 to its right under the normal curve with mean mu equals 531 and standard deviation sigma equals 104. That's the same as finding the SAT score X with area 0.9 to its left. Figure 3.13 poses the question in graphical form. Most software will tell you X when you enter mean 531, standard deviation 104, and cumulative proportion 0.9. Here's many tabs output. Inverse cumulative distribution function. Normal with mean equals 531 and standard deviation equals 104. P 0.9. X 664.281. Minitab gives X equals 664.281, so scores above 664 are in the top 10%. Round up because SAT scores can only be whole numbers. Figure 3.13, locating the point on a normal curve with area 0.10 to its right, for examples 3.9 and 3.10. So you can see that if you want an area of 0.1 to its right, you want an area of 9.0 to its left. Without software, use Table A backward. Find the given proportion in the body of the table and then read the corresponding Z from the left column and top row. There are again 3 steps. Unstandardize a Z score. Step 1. State the problem in terms of the observed variable X. Draw a picture that shows the proportion you want in terms of cumulative proportions. Step 2. Use Table A to find the entry in the body of the table that is closest to the cumulative proportion you want. Determine the corresponding value of Z in the table. Step 3. Unstandardize to transform Z back to the original X scale using X equals mu plus Z times sigma. Note that the value of Z in Step 2 may be a negative number. Example 3.10. Find the top 10% using Table A. Scores on the SAT Critical Reading Test in 2018 follow approximately the N bracket 531, 104 and bracket distribution. How high must a student score in order to place in the top 10% of all students taking the SAT? Step 1. State the problem and draw a picture. This step is exactly as in example 3.9. The picture is figure 3.13. The X value that puts a student in the top 10% is the same as the X value for which 90% of the area is to the left of X. Step 2. Use the table. Look in the body of Table A for the entry closest to 0.9. It is 0.8997. This is the entry corresponding to Z equals 1.28. So Z equals 1.28 is the standardized value with area 0.9 to its left. Step 3. Unstandardize to transform Z back to the original X scale. We know that the standardized value of the unknown X is Z equals 1.28. This means that X itself lies 1.28 standard deviations above the mean on this particular normal curve. That is, X equals mean plus 1.28 times standard deviation equals 531 plus 1.28 times 104 equals 664.12. A student must score above 664 to place in the highest 10%. Example 3.11. Find the first quartile. High levels of cholesterol in the blood increase the risk of heart disease. For males aged 20 to 24, the distribution of blood cholesterol is approximately normal, with mean mu equals 180 milligrams of cholesterol per deciliter of blood, mg per deciliter, and standard deviation of sigma equals 34.8 mg per deciliter. What is the first quartile of the distribution of blood cholesterol? Step 1. State the problem and draw a picture. Call the cholesterol level X. The variable X has the N, bracket 180, 34.8, end bracket distribution. The first quartile is a value with 25% of the distribution to its left. Figure 3.14 is the picture. Step 2. Use the table. Look in the body of Table A for the entry closest to 0.25. It is 0.2514. This is the entry corresponding to Z equals negative 0.67. So Z equals negative 0.67 is the standardized value with area 0.25 to its left. Figure 3.14. Locating the first quartile of a normal curve, for example 3.11. Okay, so you can see Z is negative 0.67. You're looking for the X value, and you're looking for the area to the left of Z of 0.25. Step 3. Unstandardize. The cholesterol level corresponding to Z equals negative 0.67 lies 0.67 standard deviations below the mean, so X equals mean plus 0.67 times standard deviation. X equals 180 minus 0.67 times 34.8 equals 156.7. The first quartile of blood cholesterol levels in males aged 20 to 24 is about 157 milligrams per deciliter. Apply your knowledge. 3.13 Table A. Use Table A to find the value Z of a standard normal variable that satisfies each of the following conditions. Use the value of Z from Table A that comes closest to satisfying the condition. In each case, sketch a standard normal curve with your value of Z marked on the axis. The point Z with 75% of the observations falling below it. According to Table A, the Z-score corresponding approximately to the cumulative proportion of 0.75 at 0.7486 is Z equals 0.67.